derivatives. A local maximum is a point where the function value is greater than or equal to all nearby values. A local minimum is where it's less than or equal to nearby values. At both maxima and minima, the first derivative equals 0, these are critical points. On the graph, the tangent line is horizontal at both the local maximum and local minimum, the slope is 0. But f prime equals 0 alone is not enough. We need tests to determine if it's a maximum, minimum, or neither. First derivative test. Step 1, find where f prime equals 0 to get critical points. Step 2, check the sign change of f prime around each critical point. If f prime changes from positive to negative, the slope goes from uphill to downhill, it's a local maximum. Like a hilltop. If f prime changes from negative to positive, downhill to uphill, it's a local minimum. Like a valley. If the sign does not change, like positive to 0 to positive again, it's neither max nor min, just an inflection point. Second derivative test, often faster than the first. At a critical point C where f prime is 0, if f double prime of C is negative, the curve is concave down like a hilltop, it's a local maximum. If f double prime of C is positive, the curve is concave up like a valley, it's a local minimum. If f double prime equals 0, the test is inconclusive, you must fall back to the first derivative test. The advantage, you only need to evaluate f double prime at one point instead of checking sign changes on intervals. Example. Find the local maxima and minima of f of x equals x cubed minus 3x plus 2. Step 1, f prime of x equals 3x squared minus 3, which factors as 3 times x minus 1 times x plus 1. Setting f prime equal to 0, x equals negative 1 or x equals 1. Step 2, use second derivative test. F double prime of x equals 6x. At x equals negative 1, f double prime equals negative 6, which is negative, so x equals negative 1 is a local maximum. At x equals 1, f double prime equals 6, which is positive, so x equals 1 is a local minimum. The maximum value is f of negative 1 equals 4, and the minimum value is f of 1 equals 0. Two fundamental theorems. Rolle's theorem, if f is continuous on the closed interval a, b, differentiable on the open interval a, b, and f of a equals f of b, then there exists some c between a and b where f prime of c equals 0, a horizontal tangent exists. The mean value theorem, also called Lagrange's theorem, is more general, f prime of c equals f of b minus f of a divided by b minus a. This means somewhere between a and b, the tangent line is parallel to the secant line joining the endpoints. On the graph, the orange secant connects the endpoints, and the green tangent at point C has exactly the same slope, they're parallel.